Hey, this is OXDF, and welcome to the University CTF 2024. Hopefully, this is going to be an exciting time for you all, and hopefully, these talks are providing some value. Um, Today, we are going to talk about Sherlocks. And what are Sherlocks? Sherlocks are investigatory challenges meant to mirror real world tasks that you'd run into working in a defensive cybersecurity role. They come in a handful of categories: SOC, DFIR, cloud, malware analysis, threat intelligence. Um, and they differ from boxes and challenges on the platform in that you're not just seeking a flag, or you're not trying to read a root.txt. And if you think about it, it doesn't really work that way for a defensive investigation. In a red team challenge, you start off with no access. We give you an IP address, and you have to figure out how to get that access. And as you get more and more access, you can read files that give you a flag and you can report. The flag is your way to prove that you've earned that access. But in a defensive investigation, you you start with everything. You've got access to everything, and you've got to figure out what happened. And so it's less about gaining privilege and more about unraveling a mystery and trying to figure out what happened. And so to that end, in a Sherlock, we're going to typically ask you 10 to 20, maybe a few less, few more questions that if you can answer all of them, you solve the Sherlock. And these are asking you the kinds of data that you would want to turn in if you were writing a forensics report or an incident report. These are the facts that you would want to include in that report. And so that's how you prove that you've unraveled the mystery. Another fun thing the Sherlock's team does is operations. And this is a nice segue into Tinsel Trace 2024. From December 15th through December 22nd, there's going to be 6 Sherlocks released. And they're going to all be active, so no write-ups, no spoiling, through January 7th. And then after that, we'll produce our write-ups. You can produce your write-ups, put it out on blog posts, and the solutions will be available. I believe they'll be free for all players through the end of January, and then they'll go to our VIP subscription. So this is a really fun event. I encourage you to jump in, play along. In this year, Krampus is coming after Santa's workshop at the North Pole. And over the course of these challenges, you're going to see the initial access, work through a compromise in a Kubernetes cluster in S3 data archives. There's a mobile analysis challenge. There's even an AI attack that goes on. So it's a lot of fun. I'm going to encourage you to come play with us later this month. With all that in mind, today I'm going to do one of the challenges from last year's Tinsel Trace. It's actually the third one. It didn't have a specific name other than Op Tinsel Trace number 3. So we're going to pull that up here. Let me grab a window here. And this is what the Sherlock pages look like. And, it's a series of questions. We'll note most of the questions are available right away. They don't have to be answered in order. Although I often find that I just start working through from the top. And, if I get stuck, you can move on and you don't have to work them in order. But a lot of times it's useful to work them in order. You'll see some aren't available yet. And that's typically because something in task 5 in the question maybe spoils the answer of task 4. There's another example of that down here with task 12. And up here, I've got the artifacts I can download. So I've already downloaded this file. The code for the zip you download is hack the blue. It's always gonna be hack the blue, I think. But you can copy it here just in case. So yeah, let's go ahead and jump in. I've got these already downloaded in my VM right here, Op Tinsel Trace 3. We'll unzip that right here and hack the blue. And it's gonna take a second because of course, I skipped ahead. Let's go back. The Tinsel Trace Sherlocks, all Sherlocks start with a scenario. And so, this one says, oh no, our IT admin is a bit of a cotton-headed ninny muggins. Byte Sparkle left his VPN configuration file in our fancy private S3 location. I think, if I remember correctly, Op Tinsel Trace 2 last year was actually analyzing a breach of the S3 location. And so that's one of the things we do in these operations is the story kind of moves through. So when the S3 got breached in Tinsel Trace 2, we lost the VPN key, and now the attackers have gained access to our internal network. They compromised one of our TinkerTech workstations. Our security team has managed to grab you a memory dump, analyze it, and answer the questions. Santa is waiting. And these Sherlocks are built to be played in order. So we're skipping ahead, but it's okay. You can solve everything without having solved the previous ones. There's just a few hints that are clearer if you have solved them in order. So let's go ahead and jump over here. Now, as I get going, I'm going to talk a little bit more about volatility in a second, but before we start, there's a command that I like to run first that takes a minute. So we're going to start that. I'm going to go ahead and move tinsel trace Santa Claus.bin. Oops. Move tinsel trace Santa Claus.bin to here. Move dir tinsel trace 3. Sweet. I've got my bin. If we run file on this, it's just going to say data. But the scenario told us this is a memory dump. So we're going to use volatility, passing it Santa Claus.bin, and we're going to run windows.info.info. This is, to me, just a really good way to check and see, are we actually dealing with a memory dump? What does it mean? What does it look like? What's the OS, etc. If this was actually a Linux memory dump and it wasn't Windows, this would have come back completely failed. But because it returned all this information, we can be pretty clear, we have a Windows 10, major operating system version 10. It's got the timestamp of it was collected, etc. Although that doesn't look very accurate. So we can feel pretty good. This is a Windows memory dump. Sometimes that takes longer than it just did. I was expecting it to take a little longer, but since it didn't, I want to talk about installing volatility. Volatility is one of those tools. It is the go-to memory analysis tool. It really suffered in the Python 2 to Python 3 transition. I don't know, what was it, 5-10 years ago probably now? Python 2 was deprecated in favor of Python 3, and there was a bunch of breaking changes, and volatility was one of the ones that they basically started to rewrite it from scratch. It's pretty good now. But Volatility 3 has been kind of painful. I don't recommend you go back and try to get Volatility 2 working. Python 2 is dead. You don't need it in your life. Just figure out how to do things with Python 3. With that in mind, I like to install, so you pip install Volatility 3 is how you would install this. Typically, if I try to run this right now, it's actually going to fail because Python now wants you to install within virtual environments. That gets very confusing. The rule of thumb I use is if you're trying to install a command that you're going to run otherwise, use a tool called pipex. There's also another one called UV that's nice, but I use pipex. And what pipex does is it creates a virtual environment, installs that tool into it, and then puts the binaries that you're supposed to get access to into your path. And so if I do pipex list grep vol, we see I've already installed this. You run pipex the exact same way you run pip. So I would just run pipex install volatility 3. And that gives me access to the vol command right here, which is volatility 3. And that's what you saw me run above right here. Volatility takes an image with a -f and then a plugin name to run. So we ran windows info.info and we got some info. I'm going to go ahead real quick and open up a tmux window here because I'm more comfortable working on a tmux if we need to create some more terminals. So now we'll run vol -f. There's a couple things I want to run. Volatility's got a huge amount of plugins. I recommend you go read the documentation for all the things you can do. We're going to start with a couple that I like to run and get into a file. So we'll call windows.pstree, and we'll save that to pstree. And it takes a minute. Both of these are ones that just produce a ton of output, and it's just nice to have. I don't want to run it over and over again. So this one is windows.filescan pstree, file scan. And now I've got both these things. And this is, so basically I've got a list of all the files that can identify in memory and all the processes that are running. And those are things that, again, I'm going to want to refer back to over and over again. And, but I don't want to rerun these commands every time, especially if this one takes a minute, which it seems to be doing. While that's running, we can look at the process tree. So I'm going to do a less -capital S for pstree. And the reason that capital S is what does to basically don't word wrap. So now I can step through, it's just roll over. And that's really nice for pstree because it's meant to be viewed. You can see like PID4 is system, and then you can see the first level things, and then you can see 716 as a child of 488, etc. And so it's just a nice way to sort of see how the processes are laid out. We can sort of look through here. Present.exe is definitely interesting. I don't know if that's one of Santa's intentional working things or if that's malware. We'll come back to that. I don't know if we'll get to it in this video, but it's definitely something I'd want to investigate. They're definitely running MS Edge, which is fine, but might be worth keeping in mind. That's probably what's jumping out at me here. Nothing else too so exciting. Let's get out of there. Our file scan is done. And I do remember one of the first questions was about an interesting file. And so let's take a look at the file scan. So last file scan. And there's a lot of stuff going on here. You can take a while and explore. I'm going to jump ahead a little bit because it's not that interesting to watch me just sort of poke around in a file scan and say, let's cat file scan here and grep for users Santa Claus. Did I spell that right? No, I did not. Let's see. We will build this up from scratch then. Santa. All right, this is what I want right here. Grab this. All right, grep. Whoa, typing. Like that. Nope, I think I need to double escape these backslashes. Boom. Okay, we got it here. And I want to get rid of app data because I wouldn't rule out app data as interesting, but just for starting, I'm going to take it out for now. And let's go into less so we can see our results. And right at the top here is present for Xana.zip. I think if you did the previous Sherlock, this would be even more clear. But if a little bit of exploring around, this is going to be the interesting file. If we kind of scroll through the rest of this, a lot of this other stuff is just kind of default stuff. But present for Xana.zip sitting on his desktop. Interesting. Let's take a look. So the next thing we want to do is we want to actually dump that file out of memory. And we can do that with the dump files plugin. And for that, let's see, we'll come down here and we will do vol -f santaclaus.bin, and we will run windows dot dump files, I believe. And then we just do, we can do a help on this to see how it works. Oop, did I not get it right? Invalid. Is it just dump file? Dump files. I think that's right. Maybe I just didn't do the help right. I'm gonna try it with, I believe it's vert address, and then I need this address right here. So this address is telling me where it is in memory. I'm gonna take that and put it here. No, I've got a typo here. Oh, I'm doing window. Okay, we're gonna go back here and try Windows. It helps if you can type. So dump files here, you can give it an address here of the single file. If you don't give it anything, it'll just dump a ton of files. Really, really mess up your file system if you'd like to keep it neat. So we'll come up here and we'll do what we were just going to do. We're going to make it Windows dump file. We're going to give it the virtual address of the file we saw in memory, and we'll run it. And it takes a minute to go through memory, and it pulls out present for Santa, and it saved it as this long thing. If we run a file on file.stat, it is a zip archive. So we pulled that zip archive out of memory. We can unzip -l that. My favorite, if you learn nothing else from this video, hold down Alt and push period will pull up whatever the last thing on the previous line was. So, and if you push it again, it goes backwards, so you can just go back over time. This is just a bash hack, but it makes me so much faster when I do an unzip-l. So now I'm going to do an unzip and Alt period, and boom, I've now got my thing. Anyway, Alt period, great hack. Okay, so we've pulled this up, and this looks very suspicious. Right away, I've got a link file and a present.vbs. So this is how we know. In fact, we should go, we should answer some questions. I think we can already. What is the name of the file? So it is, go ahead and get present for Santa.zip is what it's called. We'll copy that and come back here, paste in, and we got that one right. What is the name? What file name is used to trigger the attack, including file extension? So let's go back to the VM here. You gotta guess it's probably click for present, but let's take a look at it. There's a couple ways we can look at a link file like this. Real simple. If we don't have anything else installed, we can do strings. Usually Windows stuff is going to use the 16-bit little endian, so that's what the -el in strings is for. If we don't do that, so we can do present for Santa, click for present. We don't get a lot. We get some strings actually. We can say it's going to run PowerShell. Looks like. But if we do -el, and it's very Windows to be like mixing its string formats. But this is even more interesting because now here we go. I got PowerShell looking here, and I've got the full command line. So this right away, if you've got any experience in doing any kind of SOC work or anything, this will jump right off the page at you. PowerShell, it's running execution policy bypass, it's encoded command, and then a base 64 encoded string. So PowerShell is gonna be nice enough to decode that for us and run whatever's in the string. We got what we want. I'll show you. That is one way to do it quick and dirty. Another thing, there's a tool called link info like this that I really like that I run. Oops, let's see. Oh yeah, that's right. And if we run that, it gives us all kinds of stuff, but most interesting, so right up here at the top, it gives us rather than just looking at the strings, we can actually see exactly what's going on. So you can see here's the icon location, here's the relative path to the binary that's going to run. It's going to run PowerShell. Here's the command line arguments that it's going to run. So we piece that together, but now we kind of like know. We didn't just kind of guess that. You could see an actor putting weird, description. I didn't know what that trick or when I was looking at the strings, like trick or treat B. What is that? I don't know what that means. Is that part of the path? But down here, I can see that's actually the description. So anyway, just another way to go, but it's a neat tool to have in your toolbox. So we will grab this string right here. Base 64 for me. Oops. Echo. Paste. Close. I don't know if that's going to work or not with that extra spacing, but then we'll just do base 64 minus D, and it worked. So the link file, if you click on it, is going to run PowerShell that is going to run file, going to recursively search for any VBS files in all of C users with recurse files, and it's going to save them as file. And then it's going to basically get the full name and C script that file. So it's going to run the VBS file script. So we can feel pretty confident that that link file, if I can find it right here, click for presence.link, is the answer to our second question. Let's see. Looking good. Now, you can argue we probably should have made task 3 unlock with task 2, because you can see right here, what is the name of the file executed by click for presence.link, including the extension. We've got that right there. Let's see. It's going to be, well, actually, I mean, in theory, it could be any VBS script, the first VBS script that's found in the users directory, but it's almost certainly going to be the other present.vbs file here. So we'll take that and go back over and get ourselves some credit. What is the name of the program used by the VBS script to execute the next stage? So let's go back over. Now we need to start taking a look at the VBS script. I'm going to go ahead and open up VS Code on this directory. Yes, I trust the authors. Presents for Santa VBS. And what do we have here? For one, I'm seeing a very common technique, which is to just jam a lot of junk in there to make it look confusing. And that's one of the cool things about opening up in VS Code is I can see all these like green lines that are just like strings that literally are comments that literally do nothing. And leave a comment in VBS, a single quote starts a comment. And so all this is just comments. This is all garbage. So I can just like delete this. You can see looking over in the side view, look at all that green. There's little hints of other colors in there, but there's so much green in here. So the first thing I'm actually going to do is go back here and we will do a cat presents for Santa present.vbs into grep -v for get rid of. Then I'm going to start the line with, oops, I better do a double quote, start the line with single quote like that. And that is going to return to me all the lines that don't start with a double quote. Put it into less just to see what it looks like. And that is looking much more like code I want to look at. So let's do this. We'll save that. We'll pipe that out to present deob.vbs. And now we can come over here and we've got that right here. This is looking better, although it's certainly not done. There's a bunch of stuff going on here, a bunch of constants being set. It's, I don't want to delete these yet, but it's very likely these are all just like, is this being used anywhere? Let's see, copy, Control F. This is 1 of 1. So this line right here is set and never used. So we could probably get rid of it. We could probably get rid of, we could probably get rid of these. For now, we're just going to ignore them. This is definitely interesting. WScript plus shell. So we're getting a shell object. We are, let's see, creating an object. We're creating a WScript shell object, saving it as that. Now we are, what is call process? Okay. Oh, WMI service. So we're going to use the WMI service to select all the we're going to loop over all the processes that are running on the current machine that we fetch with WMI. We're going to save those as call processes. We're going to loop over those. And if in the string is the character S, which is what BB, so in string is going to return the index of the character S in the process name. When it finds it, if it's not found, it's going to be 0. And so this says if BB is not 0, then exit. Otherwise it loops. And so it's going to loop until it finds a process that has a lowercase s in the name. Then down here, unrustling is going to become, it's going to basically do mid the process name, that index, 1 character. So this becomes S. This is all, the whole reason we just get all the processes is just to get the character S, so we can then say this thing is equal to power plus s plus hell. So we just created the string PowerShell in a very complicated way. But attackers do this because if you just put the string PowerShell there, the EDR and antivirus know to look for the string PowerShell. And so by putting the string power and hell, well, maybe those aren't as bad, and maybe that's not something I should flag. So that's how they chose to do it. So we've got PowerShell here. In fact, we could, let's see. I don't know if I'm not getting the ability to rename, but we'll copy control find. It is used down here on this last line. I don't know what to figure out what that is. .run PowerShell plus 34, which is space. Is that space? What is 34? Let's see. Oops. Man, let's see. I always just go to Python. Char 34. Quote. Oh, okay. So PowerShell. Oh, there was a space actually in that PowerShell line. Then this is quote A4 quote, and we're done. So A4. What is A4? I don't know why there's all these empty lines here. We can get rid of that real quick. A4 is all of this junk. And now, again, this is where VS Code makes it really nice for us because we can see right away all the comments are colored out. So nothing super exciting there. We'll get down here. We've just all this. It's just a bunch of text. Ignore the comments. And at the bottom here, we run A4 equals replace A4, the word Grinch with a lowercase I. So we need to keep that in mind. With that in mind, let's go back to our terminal. I'm going to cat present Deobfuscating VBS. I'm going to just do a grep for A4. And I'm going to put that into present Deob2.vbs. Actually, present Deob.py, because I like using Python, and this is starting to look very close to a Python function for me. So now that we're back in here, let's open the Python. I'm going to delete you. I think if I can find you. Where's really? Remove. That was Alt period. Just holding down Alt hit period twice, and I got that VBS back up. Very, very fancy. All right, so we're in here. First thing I need to do is I'm going to say, for this to work in Python, I need to set A4 to be something. So I'm going to say A4 equals empty string. I can click here and hold in VS Code. This is one of those things where it's really useful if you know tricks to do this kind of thing, whether it's in VS Code or in Vim or whatever you're comfortable with. In this case, Alt Shift allows me to start getting, I don't know if you can see it clearly on the screen, but I'm getting a big cursor. And I'm just holding that down, holding Alt Shift and then pushing down, and my cursor is getting bigger and bigger. And let's see, I get to the bottom here. And now I'm going to let go. Oh, I'm going to hold down Shift. Oh, I lost it. All right, hold on one second. We'll try that again. Before we do that again, I'm going to go to the very bottom. I'm going to clean this up. We don't need this thing because it doesn't make any sense. I'm going to get rid of this for now because these are just comments. Get rid of you. Let's get rid of you because you're just a comment after an empty string. You are like that. And now, okay, again, I'm going to do Alt Shift, hold the up arrow, and go all the way to the top, making a big cursor. And then I'm going to push right. Ooh, why am I doing, what's happening there? All right, we're going to do this one last time. And then if this doesn't work, I'm just going to switch to Vim. Alt Shift, move to the top. I think my problem is I really want to avoid the top line. So when I get close to the top line, I'm going to slow down a little bit. Now I've let go of the up arrow. I'm just sort of slowly pushing it up. I've got it to here. Now, if I let go of Alt and just do Shift, there we go. See, this is, okay, I've got some problems here. Let's go back. I don't want that. If I let down Alt and, end is what I wanted. Okay. Take 3. Hold Alt Shift, push down. And I usually do this in Vim, but I thought VS Code was probably more applicable for a larger audience. We go to the very bottom. We now let go of the Alt, hold down the Shift and push End, and boom, we've deleted, after 3rd time's the charm, all of those comments. I don't quite know why I've got a few here that are like now pulled up a line, but we can fix that real quickly manually here with just a few clicks and enters, and only a few more to go. And basically now we have a Python script, because this is valid Python at this point, that is going to build our A4 string for us. And let's see. Is that it? We're getting close. Okay. Now we'll come down here and we'll say res equals a4.replace. We want to replace Grinch, I believe it was, with the lowercase I, and then we're going to print res. And if we go back here and do Python thing, let's see. No such. Did I not save? Oh, because I did the VBS.py, and boom, we've got, I mean, it's kind of junky, but we got PowerShell here. In fact, I'm going to grab this, and we will jump over to CyberChef. And this is the GCHQ CyberChef. I paste it here. There's a nice beautify, generic code beautify. Copy you, and we will come back and vim ES1. And we will insert, paste, and we'll get out of here. We'll go back in VS Code to look at this. Let's see. So I think we've got some questions we could probably answer at this point. Let's go back here. What is the name of the program used by the VS script to execute the next stage? Oh, well, that's going to be PowerShell. Feel pretty confident. Is there a placeholder here? Example. The name of the program. I think it's PowerShell. Oh, it's not PowerShell. Name of the program used by the VS script to execute the next stage. Let's see. Let's figure out what that is. Go back. I think we need to go back to the VBS script. Oh, I bet it's PowerShell.exe. It said file.extension. I should have known better. Okay, what is the name of the function used for the PowerShell script obfuscation? Back here, I can actually see, where's my deob ps1? We have a function named wrapped present. So that seems like a good shot here. We'll go with that. And that is correct. Sweet. What is the URL that the next stage is downloaded from? And let's see. That looks like, let's see, I lost my VM. We are going to do some more deobfuscation. So we can take a quick look. What do we think these are doing? So each of these wrap present takes on a string like that looks kind of like a story, but it's a little bit messed up, and it passes it in. It gets the length, and then it says it starts an index at 6, and as long, I don't know why there's an extra space there. Let's get rid of that. As long as that index is less than the length, then it's going to add malice is equal to malice plus the next string, one character, and then we jump 7 characters forward. So we're going to go every 7 characters. So we're going to start with this H, T, T. Where I think I know where this is going already. P, colon. Okay, so we know what to do at this point, right? So how do we could, in fact, VS Code's even been nice enough to open up a PowerShell terminal for me. I'm going to be more comfortable just make this be so quick to turn into a Python thing. Let's see. Let's not mess this up. We will copy that to. Does that already exist? We'll call it deob3.py. My names are getting bad, but all right, we'll go with it. We'll say def wrap present takes in that thing and becomes a colon. We get rid of you, become len -1. And now we're going to say, in fact, we could just do this, I think. Let's check this out real quick. If I come down here, let's go back up to a Python shell and say x equals, doing this on the fly, I've not prepped this. If I do x, boom, boom, 7. I start at 6, does that? Yeah, okay. So start at 6 and then take every 7. I don't even need to write a script here. So right there, I get a URL. Is that what they're asking for? What is the URL? So we can grab that. I should explain what I just did. So in Python, I saved this string I had here as x, just because I'm being lazy. And then this says, when you do x of 6, it gives you the 6th character, right? If you do x of 6 to 8, it gives you 6 and 7, and it doesn't include 8. If you do 6 to the end, it gives me 6 to the end. if I do 6 to the end, if I give it another thing, so if I do like 6 to 14, take 2, that means give me every other character. It means instead of jumping by 1 each time, jump by 2 each time. What this says is start at the 6th character, go to the end, and give me every 7th character. And that basically is what this whole function right here is doing. And I just use that to get the URL. Grab that. And I believe I'm getting to be over time. So I'm probably going to call it here. There's more fun deobfuscations and stuff to go. This is a neat challenge. Yeah, come join us for the Optinsel Trace 24. It'll be a lot of fun. There's some interesting challenges, lots of cool technologies, and I think you'll enjoy it. I hope you have a great week at the University CTF, and I'll see you around. Thanks.